Okay, Roger, no, don't stop me.
Hello, guys.
Excuse me, sir, please, can you mute everybody?
I will do that. Let's just greet ourselves first. It's been a long time. Hello, guys. How are you guys?
We are fine.
Sir.
All right. You are welcome to another very beautiful class today. I hope you are with me. Okay.
We are fine, wonderful.
End of today's class, I'm going to be discussing with you guys how I'm going to be discussing with you guys how the new system that we're going to embark on. Are we together? No. All right. If you actually ate chicken during Easter, say hi. Nobody ate chicken during Easter. Nobody ate chicken during Easter, right? Nobody ate chicken during Easter. Hello, guys. I said nobody ate chicken during Easter, right? Nobody. You enjoyed chicken. Did you remember? Okay. It's time to get back to work. And I want to. Okay. All right, guys. I think that's enough for now. You know the way we go about it. If you have a question or anything, you can just ask. It's not time for attendance yet, please, so that I will not miss questions. So I will advise that you just wait until time for attendance. Did we get that covered? Okay, so today we have just two subtopic to handle. After we are done, I'm going to try to quickly walk you through the new concept of Google Classroom. I think you guys should be grateful for this effort being put together, so that by the time you are out of this place, you are a better person. Someone is not just coming from one place outside Nigeria telling you, we use online class in our school. No, you know, this is the real online class. And I want to believe that some of you really appreciate this. I know some people may not really like all the stress, but the bitter truth is, I'm really spending much to get this done, taking much of my time to study more so I can make things better for you. So I would like it, the best you can do for me as a source of appreciation is to really take good use of this and really have good performance when it comes to the exam. And I wish all of you the very best of luck. All right, so now let's look at what we have today, implicit functions. Implicit functions. So what are implicit functions? It's so very interesting and straightforward for implicit function. Now the differentiation carried out up to, excuse me, let me get my pointer. Okay, so the differentiation carried out up to this point involved equations that could be expressed in form of y is equal to function of x. All of you remember that. However, equations of some course, such as 3x squared plus 2y squared minus 3xy is equal to 2, cannot be easily written in order to isolate y. Now, a relationship where y cannot be explicitly given as a function of x is referred to as implicit function. So in short, what are we trying to talk about here? We are saying, okay, what if you had to differentiate an equation whereby you have y joined alongside with it? How do you go about differentiating them? So we have 3 examples here that should help us understand this beautifully. And I can assure you, you will see one of these 3 examples in your exam. So I'd like you to take note. And if you have any challenge, you can ask questions on the chat box. I'll be willing to unmute you so that you can ask your question. So let me walk through this example with someone. If you like me to walk this through with you, I'd like you to quickly say I. The first 2 persons that say I will mute them so they work with me. Okay, I'm waiting. Just 2 persons. Okay, Yakub Azizat, 1, and one more other person, Ayomide Akin Misikoke. Those are the 2 persons that will be walking the example through. I mean the first example. I'm coming, let me Ayomide Akin Siko. Hello, Ayo. Ayo, are you there? Oh, man. Ayo, it's unfortunate. I don't know what's going on. Are you there?
Hello, sir.
Okay, Ayo, you are there already, Abi? Okay, good.
Yes, yes.
So let me just release Aziza too. Azizat. Hello, Azizat.
Yes, sir.
Good, good, very good. Can I see you guys' face so I can be sure you are following? Unmute your camera. Open your camera so that I can see your face. Okay, Azizat, very good. So where is Akeshiko Ayomide? Very good. All right. Okay, so let's walk through this together. Then the first example. Are you guys ready? Okay.
Yes.
So now check this out. X raised to the power 3 plus 3x y raised to the power 2 minus 2y cubed is equal to 3. Now the point is you want to differentiate this. You know, we usually differentiate d dx. You remember that, right? That's how you have dy dx. So what that actually gives you at the end of the day is you have a result that your dy dx is equal to something. Now we are having x and y. How do we bring these 2 together? That's what we are looking at here. Now check this place. You firstly apply the rule d dx of x cubed, d dx of 3xy squared minus d dx 2y cubed. Then this also will be differentiated, d dx. You remember this rule? This is called nominal rule. You remember that? Ayo.
Sir, yes, sir, yes, sir.
Remember nominal rule. Azizat, your mic is off. Azizat, your mic is off. Azizat. Okay, so let me move on. So I just want to be sure the 2 of you are following me. Now, you differentiate them using nominal rule. So, and that's what we are applying. Why are you laughing, Azizat? Why is she laughing? Okay, so you differentiate them. You differentiate them using nominal rule. So, you know, if you are differentiating x cubed, what will it give you? Azizat, help me. If you are differentiating x cubed, what will it give you? You have muted your mic, Azizat. Stop muting your mic. Okay, yeah, speak up, Azizat. Differentiate x cubed, what will it give you?
3x is to the power 2.
Good. That's why we have 3x raised to the power 2. Now, guys, I need you to look at this place very carefully. Because you are having x and y, then you are going to use something like when we did product rule. You remember product rule, right?
Yes, sir.
You remember the way we did product rule, that you hold one, differentiate the other, add it to holding the other, and differentiating the one you earlier owed. You remember the idea? So that's the same thing that works here. That's the same thing that works here, that we are applying product rule here, kind of. So you say 3x is standing, then we are differentiating y. So you have d dx of y square. Are you following me, guys?
Yes.
Now, picking this also, you have your
Yes,
y
sir.
square, and you are not differentiating 3x.
Okay.
Is it clear now?
Yes.
Good. Now let's
Yes,
come to
sir.
the next one. This is, if you differentiate this naturally, you will now have 3 multiplied by 2 will give you what? 6y square dy dx. Now, this place is very critical. You need to get something clear here, guys. Now look at this place. When you differentiated this, why didn't we have something like dy dx? The point is you put one x here. So the x cancel the x. Are you getting me? That's why you have 3x squared and the x is vanished. Somebody did not get that part. Now you need to get this concept, this part. Azizat, are you with me?
Yes, sir. Yes,
Now,
sir.
get this place. The reason you did not have dx again, ddx, is because one x that you removed here already came here. So dx divided by dx is 1. That's why you have 3x squared. Did you get that part?
Sir. Yes, sir.
Good. Now check this part. You have 3x, you're only differentiating y here. When you remove one y, are you getting me? You will still have dy left. Because
Yes,
dy does not cancel dx. It is only dx that will cancel dx.
Oh.
Now, come here. Follow this part. Follow this place. Check this place. When we are not differentiating 3x, you will notice that dx will leave totally. Yes. Because the x will cancel the x. You will now have 3y squared. So let's go to the next slide. Let's go to the next slide for better understanding. I don't know if you are following me, guys.
I'm following, sir.
Now, so that's why we are now left with 3x squared plus. Now, when you differentiate y squared, what will it give you? It will give you 2y.
2y.
2 times 3, 6. That's why you have 6xy.
Okay.
Ayomide, are you there?
Yes, sir.
Now, so your dy dx is there. You can't take it away because dy does not cancel dx. Only dx can cancel dx.
Yes.
That's why you have the dy dx there. Then you understand this. So dx already canceled dx. I told you the other time. Abi?
Yes, sir.
Now, 3y squared. Now, this one, let me show you back here. There's a problem here. Now, when you cancel x, 3 comes here and it gives you 3y squared. Did you get that point?
Yes.
Okay, good. Now, that's how you have minus 6y squared dy dx. Now, you understand that if you differentiate 3 that does not have x, everything is 0.
Yes.
That's how you have 0 here. That was how we cancel 3. Hello?
Yes, sir.
Did you get that?
Yes, sir.
Good. Now, you now want to collect the like that. You see, dy dx is here, dy dx is here. Bring them here. So you have 6xy, you have minus 6xy squared dy dx is equal to, now bring this one to the other side, minus 3x squared. Then this one also goes to the other side, minus 3y squared. Do you now understand what happens here?
Yes, sir.
For clarity, Azizat, for clarity, dy dx multiplied by 6sy will give you 6sy dy dx.
Yes, sir.
You understand now? Dy dx multiplied by minus 6y squared will give you minus 6y squared dy dx. Do you now understand the concept?
Yes, sir.
So you cannot divide both side by this so that you can only have dy dx. Is that not what we are always looking up to? That dy dx is equal to Abi? So your answer is dy dx is now equal to minus 3 of this. You should be able to do this. Minus 3 into bracket x squared plus y squared over 6x into bracket x minus y. That's your final answer. I hope you know there is a step between this place and this place.
Yes.
Hello, Azizat.
Divide both sides by
I hope you know there is a step between here and this place.
Divide both sides by the other side.
Exactly.
Yes,
then you now look for the like times also. 3 is the like times here. 6y is the like times here. Is it clear?
Sir,
Yes.
some people say they don't understand.
Who didn't understand?
I understand, sir.
Don't help. Omojola fi Ifeoluwa. Promise Oyekule, my goodness. Everybody, Adura. Gosh. Okay, I will take it all over again. Let me mute the two. Okay, the two of you mute yourself. Let me release. Let me see. Adura.
Okay, sir.
Promise. Okay. Who did you say did not understand in the first place? Okay, let me release Adra and Promise. Let me walk them through this. Hello, Promise.
Hello, sir.
Okay. So I'll quickly explain this again, right? Adra.
Yes, sir.
Are you there?
Yes,
Promise,
I'm here.
you need to unmute yourself so that I know I'm talking to the two of you. Promise. Promise and Adra,
Okay,
unmute
sir.
yourself so that I can talk to you guys directly. Are you there?
I've done.
Hello,
Yes,
Promise. Okay, good. Now check this place. I really have to quickly be fast with this. Now check this. We say we are trying to differentiate, however, there is X and Y together. Are you following me?
yes.
Now, I said, do you remember product rule?
Yeah.
That if you have something like cos 2x, cos 2x, 3x, you differentiate cos 2x and hold 3x. You differentiate cos 3x and hold. You remember that? Promise.
Yes. Yes, sir.
So that's what I've played out here. Now, if you are differentiating with respect to x, 3. Hold on, guys. I'm coming. I need to check something.
That one, sir.
Sorry, I had to go and check my. I hope my soup is not getting burnt. Okay. Are we back? So now check this place out. You just have to concentrate here. Adra, concentrate here.
Okay.
Now you understand this one naturally, Abi.
Yeah.
I'm saying, have you
Yes,
ever
sir.
wondered why we normally cancel ddx when we differentiate x cube? Now, this is what happened. You remember that we remove one x here. We have x squared. Now, that x will join this d. I hope you know d is multiplying x cube. You know, your Promise, are you there?
Yes, sir.
Are you following me now? So now what played out here actually is that x joined this d. So the x will cancel the x. That's why you now have 1. So 3 multiplied by x will now give you 3x squared. That's what happened to that 1x that you remove from here. It actually canceled this dx. Did you get that?
Yes,
Your face doesn't look like you understand this part. Did you? Hello? Are you sure you understand this?
Hello, sir.
You did not.
Yes, sir.
See, you
Yes,
should
sir.
understand that when you differentiate x cube, what will it give you?
Yes.
Now what happened? You know, you remove 1 here. That's how you have x squared. Abi? This one that you remove from this place is what made you have x squared here. Hello, Adra. Okay, let me show you guys. I think my time is almost up. Okay, can you see my whiteboard, guys? You have G X. Are you getting me? Are you with me?
Yes.
Over
Yes, sir.
X. I hope you know this is the same thing as what we had today, Abby. Promise.
Sir.
I hope you know this is the same thing as what we had today.
Yes, sir.
So now this can give us dx. Are you getting me? X square over dx. Are you following? So this dx, we cancel this dx because dx, that's why you now have your 3. You understand the idea of multiplying 3 first. That's why you now have 3x square. Are you? But if you have the y over here, let's assume this is what you have. Are you getting me? The answer will become 3y square. Hello, I am in class. I did class. Now, this will give you 3y square. Are you getting me? dy over dx. Because dy cannot cancel dx. Dx was able to cancel dx. Are you getting the idea now? But dy cannot cancel dx.
Yes,
Is that
sir.
part clear? Is that part clear? Eh? Now our 40 minutes is up. We will soon be locked out.
Yes, sir.
So that we'll log in
Yes, sir.
back so that we can pick it up from this part. You understand now? Who is asking these people to write attendance? For how long will I ask you not to be writing attendance when you enter? So that I will not miss people's questions. Bukola, don't be stingy. Okay, so you understand that concept now, Abi?
Yes.
So that was what that played out here that made us have 3x squared. But when we got here, we had 3x